Law Center in Baton Rouge, Louisiana, and I'm here to talk about our implementation of IPsec for keeping viruses, worms, that type of thing out of your Windows machine. You have firewalls for your main campus that keep the stuff from outside out, hopefully. The stuff from inside, your own machines, you need protection from also. Well, let me start this presentation. How many, that's my audience here, how many of you are network people, network sysadmins? Okay, and what about server-side PC management? Most of you both, yeah. Okay, and what about, I guess, technically oriented type of people that not, maybe librarians, maybe media services type of folk? Okay. All right. So we have a pretty technical audience here, and I'm aiming somewhere between technical and the high side of moderately technical. So, what's the problem? Viruses, worms, and Trojans. Hackers are trying to get into your PC either personally or remotely, through worms that are spreading on their own, and it's a real problem. 2 years ago, we had, I think, well, everybody had that problem with the, I can't remember the name of the worm that went around. Everybody was infected in one afternoon. Our help desk got a call from one secretary, and my computer's shutting down, and 5 minutes later, another secretary, and another faculty member, and then another secretary. And that was when I decided now's the time to make it so that these computers are protected from other machines on our own network. We were already protected from machines outside of our network by campus port filtering. They don't really run a firewall, but they port filter most of the malicious ports. Why would you want to run something in addition to just patching your machines? Well, some stuff gets exploited before there is a patch. A lot of stuff never gets patched. And here we have network-based firewalls. That's usually run by the main campus. How many of y'all have control of your own firewall for the law school? Okay. And how many of y'all have very little control over a firewall on your network? Little to none. Okay. That's our situation at LSU. The main campus runs what little bit of intrusion detection that they do. We don't have much input on it, and also within the campus, there's nothing protecting our department from the engineering school or other areas. There's nothing in between departments. So we've got about 20,000 hosts on our network, I believe, last count. And so just a small percentage of them still is a lot of hammering. If you bring up an unprotected machine on our network that's not patched, it'll be infected in 5 to 10 minutes. So this is really important. So not having access to our own firewall, I decided to firewall at the PC. I looked at some products that were all expensive to do on 200 desktops. You can do them on a few servers. So I started looking around for free options. And the free option I found was Microsoft's IPsec. It was implemented in Windows 2000, and so we're only really talking about what can be done with 2000 and XP or 2003 servers. But that's probably most of your machines, and even if you have a significant population of other stuff, that's probably most of your machines you have problems with, so far as getting infected. It's manageable. Group policy, you can do your IPsec settings, but you got to be careful because you can really shoot yourself in the foot with it. How many of you know much of anything at all about IPsec? I've really messed with it. No? Okay. IPsec's applied at the network level. So any program that you have using the network doesn't need to be aware of this encryption of the network traffic that's going on. It just happens. And so you can use it to secure Telnet and FTP and other stuff that you normally wouldn't want to use on unsecure network. It makes use of Active Directories, Kerberos, or if you have a public key infrastructure in your Active Directory already. Does anybody use certificates? You do have a certificate system, and most people are just using the native Active Directory authentication. So, okay. That's good because it works with either one, and it's really easy to go with the built-in native Kerberos authentication. You really don't even need to know anything about Kerberos. And even though this is a network defense type of thing, you don't need control of your network to make use of it because it all happens at the host. Similar to a host-based firewall, but it's different in that it doesn't do stateful packet inspection the way a firewall does. And since it is at the host, it is important that you have, it's important to have at your host protection, because if you have network perimeter protection, then you can still have an infected machine within your network, and it's not between your PC and the firewall. You need that kind of thing. What is IPsec? IPsec does the main use of IPsec. There's two basic things it can do. You can sign the traffic so that you know that the traffic really came from who it said it came from, and you can encrypt the traffic. Encrypting the traffic can be hardware intensive if you don't have a special IPsec network card. They do make those. They're best for servers. But generally, you don't need to do the encryption, because these are the options you have. When you set up your IPsec rules, it's going to, much like a firewall, look at the source, the destination, the port that's being used, and these four options are the things you can do. You can just totally block the traffic. You can require security. You can request security, or you can just permit it through without any security. And the ones that we make the most use of are block and permit, because most exploits don't make use of spoofing traffic coming in. They just connect to a port and do a buffer overrun or something like that. And they also don't make use of sniffing the traffic. So that's not particularly important. And as I said, it can be real complex because of the public key infrastructure possibilities. Kerberos is complex. If you're behind a NAT, then you have to have a Service Pack 2, I think, on XP for that to work properly. So, if you're going to make full use of all the fancy stuff, it's difficult. You need a network professional probably, or a whole lot of time studying it up. But anybody can make use of the simpler aspects of it. I'm just looking at a packet, deciding if you're going to let it through or not let it through. Okay, precautionary tales. Daryl Miller, who is at the conference with me, who works with me, made me promise to put in these precautionary tales. We once deployed a setting that cut off communication with our Active Directory. Well, we were in a hurry. There was an outbreak. This was actually the day that we got calls from one person after another very quickly. People having their computers start shutting themselves down automatically. And so we threw this together real quick, applied it in the evening, so fortunately it didn't mess up the day for everyone. And all of a sudden they couldn't talk to the Active Directory domain controllers. Well, group policy is how we were getting this policy out, and that's on the domain controller. So when you make a fix, it's got to go back out by group policy, and group policy wasn't communicating. What we had to do was visit every single desktop, log on to that desktop, which took forever because it wasn't able to log on, so you had to wait for the login process to fail, and then hopefully you had a cached profile on that machine, so you did finally get in. You stopped the IPsec services, this net stop IPsec services. And once that's done, then you can talk to the domain controller again. You do a GP update /force, which makes it go out and get the latest group policy update, which has been fixed at this point. And then you can reboot the machine and it's talking again. We did this almost 200 times through the evening. And it was a hard-learned lesson. So when you're playing with the group policy settings, be sure that you test it. Test it out on your PC first, then deploy it on a test OU within your Active Directory. And once you're sure, then you can release it on your entire domain. Same thing goes for if you preclude communication with other critical services that the machine's not going to work without DNS, WINS, and DHCP. But that one's not quite as hard to fix. You can just bring up another DHCP server, or change the address of your DHCP server so that it can't now be contacted. Set it to an address that's not blocked. All right, so how's it done? So again, who has actually looked at IPsec in Windows? You have a few, okay. And actually deployed it at your school? No? Okay. As I said, first thing you want to do, try it on your desktop instead of within Active Directory group policy. You go to the control panel, administrative settings, and local security settings. And here it is down at the bottom, IP security policies on local computer. There's 3 of them already there. You can pick one and modify it. I like to create the brand new blank policy. Name it test. And the default response rule. This is something that's always going to ask you for. You don't have to have it if all you're ever going to do is block or deny. But if you ever want to make use of the signing of the headers or encrypting of the packets, then you want to have this here. It doesn't hurt having it there, so go ahead and leave it there, then it's less of a problem later on if you try to decide to go further. You get your option of how you're going to do your authentication, and the default is Kerberos version 5 from Active Directory. And I've used this before, to actually use the packet signing. It works with no problems. I've actually know nothing about Kerberos. So, certificate authorities, you can do that, but I would not suggest doing the pre-shared key just because it's not a very secure way of communicating an encryption key. All right, so after that's done, you have to create some rules. And you see the first rule is already there, the default response. And here I've clicked on add, and it's adding a new one. It's going to ask you, one of the things you can do with IPsec is it's good for VPNs. And so you can tunnel all of your traffic over one port secured by IPsec between 2 points. So the first thing they ask you, is this related to the tunnel? No, it's not. Don't worry about that. You probably want this to apply to all network connections. Possibly you don't want it to apply to remote access, but I always use just all network connections. It works fine. Then again, it's going to ask you for an authentication method. We're not going to tell it to authenticate, but you still have to pick a method. So here are the 2 built-in filter lists: all ICMP and all IP. Now, you're going to want to create additional filter lists. You're going to have filter, and what you can do with a filter list, a filter list is just a list of specifications: this IP address, this port, this IP address, this port, and which direction, or both directions, if it's a mirrored rule. You don't have to have specific IP addresses. You can do entire subnets, or you can say any address. So the first thing, remember, I said don't ever lock yourself out of being able to talk to your domain controllers. Start off by creating your trusted hosts list and add in your domain controllers. Here I've just done 1. You can see it's a mirrored rule. I don't know why you would ever not want to mirror a rule. That means traffic addressed from me to you gets to you, but when you talk back, I don't get it. So you're always going to want to mirror, so the traffic in the other direction also gets back. Here you can see we've specified any protocol, any source, port, any destination. Any destination port. And then the destination address, that's the address of our first domain controller. So anything from me to that address should be allowed, no matter what the other rules say. So now it's been added. You want to select it, click on Next. And the 3 filter actions that are pre-built in are permit, request security, and require security. There was a 4th that I mentioned, is deny, and that one does not pre-exist for some reason. I'm not sure why. We'll get to that. All right, this is the second step. You're going to have a lot longer list than this, but name it something descriptive: dangerous ports. And what we've done here is added port 445. That's one of the ports that Microsoft does file sharing and RPC, remote procedure callover. It's a very exploitable service. Also ports 135, 137, 139. They're easy to find. Do a search on the web for firewall settings and ports that you should protect, and anything that's got Microsoft next to it. Most of those you don't want anything but your own computers talking to on those ports.
Are you guys an exchange shop?
Yes.
Doesn't it communicate over 135?
It does. We're using RPC over HTTP outside the building. Within the building it is for 135. And that was fun setting up too. It's really nice.
Yeah.
Really nice. Are you using Exchange also?
Yeah.
What version? 2003?
Yeah.
Yeah, because that's new in 2003.
Yeah.
And it only works with Outlook 2003. That's the only client that works with the RPC over HTTP.
See, our main campus, we have a firewall. They launched 135 after Glassfix came out a year and a half ago, and so now we're using stuff for access for the moment because we can't get in through their firewall.
Yeah. Yeah, you set up RPC over HTTP. Do you have a single server? Do you have front end and back end?
Single server is changed.
Yeah, that's what we did too. All the instructions you find on the web are for a front end and your back end and the gateway and all that. So you have to kind of pull all that stuff together to do it on one box. None of the instructions work. So you got to experiment for days. You can see that these rules are mirrored. Source address is my address. That's dynamic, so that if you're using, you can create rules that are specific to an IP, but you can have a dynamic one that's just my address. So it'll change if it's a laptop somebody takes on a trip, or if you just have DHCP and the addresses change on a regular basis. Source is my address, and the source port is 445. So what we're protecting on this PC is 445. Incoming connections could originate on any port. It's not 445 to 445. It's any port to 445. So what we have is from any address. We're not going to accept that traffic. And those services that Microsoft runs on 445 use both TCP and UDP. You'll find that when you go and look for firewall settings and what ports, it'll tell you what protocols. It'll tell you the port and the protocol, and probably the service that uses it. Now, we do have our list of trusted hosts that we created first. So with our trusted hosts, you're going to add in your domain controllers. You're also going to have your file servers and your print servers and the SQL servers and all that other stuff that needs to talk. Just have that in the trusted host list. These rules won't apply. You will be able to talk in 445. It's important. Go ahead.
Would that create a problem with using the Westlaw? Because with the Service Pack 2, a lot of them have to go there and put in Westlaw as a trusted site. Is this creating conflicts with that, or is that just only?
You said it as a trusted site in Internet Explorer, right?
Right.
Yeah, it's not really related because we're not specifying that would be port 80.
Web address.
Yeah.
Okay.
Since it's a web page. Now, if you were telling it to block access to port 80 and only giving the list of trusted hosts to connect on port 80, then probably what you'd be doing is running a proxy and not connecting direct to West. And there's two ways of doing this too. You can start off with, your trusted hosts first. Always start off with that. You start off with a rule that says drop all traffic. All traffic from anywhere on any port, drop it. And then, instead of making a deny list, you make an allow list. That's the way network security professionals prefer things to be done. It is better, but it requires more vigilance. You're going to find yourself frequently having to go and tune it up because somebody's found some plugin on the web that doesn't work, and it's because, or somebody's running a website on a non-standard port and stuff like that. It can cause problems. So I find it easiest just to find out where it is that these Microsoft services are listening and just block access to those ports instead of the other way around. All right. So now we have our IP filter list. You see the two pre-existing ones. We have our trusted hosts. And in this new security rule that we're creating here, we've selected dangerous ports. And now when you click next, it's going to want you to give a filter action. We want to deny, but that's not there. So you just click on new filter action and name it whatever you like, deny or drop. And within the security methods, you have permit, block, or negotiate. Negotiate is the one where you start having need for somebody who really knows their IPsec settings. I would say that just about anybody with a technical bent and likes to tinker with Windows a good bit should be able to play with the IPsec settings that I'm talking about here. When you start talking about negotiating security, and there's a huge list of options. And so that stuff you probably want to stay away from unless you have a real need to encrypt that data or sign those packets. So here's our test policy. We have 3 rules that are enabled. The default response rule, which is not really necessary, but it doesn't hurt anything being there. Dangerous ports, you see the filter list that's being used, the filter action, deny, authentication, which isn't really significant, but you have to pick one anyway. We also have our trusted host list, which are permitted. You may be wondering about precedents. The more specific a rule is, the more precedence it has. So if you have a rule that says drop all traffic, and then you have another rule that says this IP can communicate with this IP, then that one has precedence. And so that's how you figure it out. You can't set precedence, which is one of the things that I don't like about Microsoft's IPsec. I think with some other implementations you can, like the stuff that Cisco uses in the VPN software, and can specify the precedence of the rules. They've got a complicated algorithm that you'll never figure out, and it comes up with a weighting, which is like an 8-digit number. But it's pretty easy to figure out. If one IP to a subnet is a lower precedence than one IP to one IP. And one IP any port to another IP any port has less precedence to one IP with a specific port to one IP with a specific port. All right, this is IPsec monitoring. There's a snap-in that's useful once you have this up and running. Launch Microsoft Management Console. Go to the snap-ins. It's IPsec Security Monitor, IP Security Monitor. And the quick mode views are the most useful. I think the other ones don't really get populated if you're not using the encryption. You don't see stuff show up there unless there's some security being negotiated and you have security associations being created. These are the generic filters, and what we were creating were generic filters, like my IP to this subnet. When you look at this, you'll see each one of the filters you've created. This is our main policy that all the workstations at the Law Center have. So you can see I've got about, 25 or so rules, not rules, but filters in the filter list. And we've got our file server, SQL server, 2 domain controllers, a print server, a Lotus Notes server, a web server, a second web server. Tech2 is actually an antivirus and does network scanning to see what ports are open, things like that. I have myself, my desktop PC, Sparks. Carol is one of my technicians. Daryl is another technician. We listed us because there's going to be times, I know all of you use it, that you want to connect to the $C share on somebody's machine so that you can take a look at it. Or you want to manage their, look at services or the event log on somebody else's computer. You can right click on my computer, just select manage and select connect to another computer. That relies on port 445, 135 for RPC. So you want to include your technicians' desktops. Otherwise, they're not going to be able to be as helpful remotely.
Is that done by username or IP address?
That's done by the IP of their desktop. So yeah, if they're at somebody else's computer, they can always remote into their computer and then get to it.
Do you guys have static or dynamic? IP addresses for your computer?
Just for these few, I have DHCP reservations.
Okay.
So even when I need a static address, I usually still use DHCP to make it a reservation. But yeah, so for these, I do have static addresses for this reason. Now, if we were having us negotiate IPsec encryption or packet signing, then we could also limit it to a group of computers. And so then it wouldn't matter what the IP was. If IPsec had been negotiated for the encryption, then you could specify that host can get through based on it's authenticated, the headers are being signed. Here's the specific filters. So this takes the specific filter, my IP, and translates it. My IP is 130.39.14.43. This is the interesting part, the weight. This is where you can figure out the precedence of all the filters that you've built. I have this list sorted by weight, and the higher weights have precedence. So you see at the very top of the list is the destination is any, and the source is any. So that's going to be the lowest weight for precedence. I don't know if I scroll down on this. Yeah, further down you can see these are subnet specific. And that's the end of this presentation. And we're open to discussion and questions.
Can you change the weight?
You cannot. There may be a way of doing it in the registry, but it's not really recommended. The weights, you just have to keep in mind that you know what influences weight. You know how specific you are with IP, subnet, everything, a single port, all ports. Yes.
You guys are running your own domain.
We do. Yeah, we have our own Active Directory domain. You can still do this if you don't control your own Active Directory, as long as you have your own organizational unit, because you can apply this at the OU. You know, anywhere you can apply a group policy, you can have IPsec attached to it. Your main campus probably isn't already using it, just because not a lot of people do. So they're probably
They have the same problem. I think with somebody played with it.
oh yeah.
They all freaked out. So
It's it can be dangerous, and I shudder to think what would happen if you do it on a campus with 20,000 PCs instead of 200. Although they had a similar situation with viruses about the same time, they had to call in some outside consultants to just get enough people to come in and go through the entire campus and clean off viruses. In that same episode that prompted me to start doing this. Yes?
Are you guys not using any kind of VLANs on your switches to segregate your network traffic so RPC and those kind of things don't cross from the various ports, groups?
All of our hardwired ports within the law center are on a single VLAN and a single subnet. Wireless network within the building is separate. It's on a different VLAN, different subnet, and it's actually firewalled, which is a little bit of a problem because you can't get to Windows shares and things like that. But for the most part, our students don't connect directly to shares anyway. They can use an SFTP client to connect to their home drive. And yes.
I'm curious why you don't have your own firewall then? Is that just
I asked about it once. Yes. You know, several years ago, there were no firewalls at all on the entire campus because it was the old academic tradition of it's an open network, and the campus networking group had, anytime you brought up the issue of a firewall, their mantra is network security is host security. Keep your host secure, you don't have to worry about secure network, which I guess can be true, but in reality, nobody's going to. That works for well-managed Unix hosts, you know. But when you get desktop computers that are run by non-sysadmins, they need more protection than that. So they finally come around to it. They firewalled off the student housing, but not to protect student housing. It's to protect us from student housing.
I understand that concept.
Yeah. And they've got traffic management, a big traffic shaping box, 2 of them, that prioritize traffic through different pipes. You know, they'll allocate so many megabits to HTTP on port 80, and so things like that. So we have a huge network pipe. I think they have two or three T3s. But before they got the traffic shaping software, it was being clogged by peer-to-peer stuff. And they didn't want to totally block peer-to-peer. But what they did with the traffic shaping is they give the peer-to-peer traffic 5 megabits out of their 150 or so. And everything else flows pretty well. Any other questions? A few other things I can think of. You might want to, we were talking about on your own computer, you're protecting this list of ports. It's still possible that within your domain, you only have your PCs able to talk to your server. So even 2 desktop PCs within your domain, one can't infect the other. They could infect the server, and the server could infect back down the other way. But hopefully you're watching your server more closely, you're keeping it patched better. Even if you're doing patches through group policy, through SUS, or something like that, it can fail. If you have a full hard drive, patches will fail to apply, and you won't know about it until you sit down with that machine and see that they're not being applied. And other things can cause that. So even if you're automatically applying patches, it doesn't guarantee that they're being applied. But, yes?
Yeah, when you do laptops, you mentioned not as a rule that regular shares on your servers after your students. How do you handle that situation?
The students.
You can't roll out like you said.
No, we haven't. I suppose we could, but you don't really want to do that with the student laptops that they're taking home because they might want to be doing shares between their own machines and things like that. You don't want to preclude that. So students don't connect directly. They use SFTP client to connect to our file server. If they log on to any of our lab machines, they get a drive and a cable. It works like that. The list of ports that you're protecting on your own machine, you can create another list of ports the other way around. Set your machine so that it can't talk to anybody else on port 445 and the other ports. That way, if your machine does become infected through some other method that's not being blocked, then you can't infect machines that, say, student machines that don't have the IPsec, so they are vulnerable when they're on your network, or, in the case of our network, people over across campus in the pottery department that haven't patched their machines. They're vulnerable to your machine if it becomes infected because you're blocking 445 on your own machine, but when you get infected, you can reach out to their machine on those ports. So you can create yet another rule just to, doesn't really help you, but it's doing the good thing for the community to not be able to reach out to any other boxes on those particular ports either, because there's not a reason why your machine should. Let's see if this is still up. This is my desktop at work. And list of this, if anybody's interested in getting a little bit closer look at the monitoring of this. That's it.